Good morning, students, and welcome to online classroom of St. Michaels Academy. Today I am continuing Organic Chemistry Part 2 with Functional Group and Homologous Series. Both are very important, so please see the video carefully and do all the homeworks of previous and this video that I have given. Please give the date properly in your school copy and do the homework properly. Either you can submit your copy in school at Friday, or you can mail me through my email ID. If I know maybe first time you are studying organic chemistry, maybe you are facing some problems, don't worry. In Zoom class, you can ask me. Just jot down your problem. So let's start today's class. So here I am going to discuss about functional group and homologous series. What is functional group in organic chemistry? Functional groups are collections of atoms that attach the carbon skeleton of an organic molecule and confer specific properties. Each type of organic molecule has its own specific type of functional group. Functional groups include hydroxyl, that is OH, bond OH group, methyl, carbonyl, carboxyl, amino, phosphate, and sulfhydryl. You can see in the picture some of the functional groups has been shown. First one is amine, NH2. Please notice the single bond. There is single bond between nitrogen and hydrogen, and one bond is empty of nitrogen because nitrogen has generally variable valency, but generally we used to take over here 3. Valency has 3. So with 2 valency, it has bonded with hydrogen and 1 valency is free. In case of carboxylic acid or in case of organic acid, COOH group always present. Already I have told this to you in previous class. So like formic acid, HCOOH, acetic acid, CH3COOH or vinegar, like this. So COOH, please see the structure of this. C double bond O and C single bond O and O single bond hydrogen, and one bond of carbon is free because carbon has valency 4 and oxygen 2, hydrogen 1. Alcohol, organic alcohol, contains OH group, methyl alcohol CH3OH, ethyl alcohol C2H5OH, like this. Here also one bond of oxygen is empty as valency of oxygen is 2. And the last one is isocyanate. This is a new bonding, new functional group. Nitrogen, double bond carbon, double bond oxygen. And one bond of nitrogen is free. Now in the next step, it has been shown that amine and carboxylic acid form amide. See the structure just. Carboxylic acid and alcohol forms ester. Ester means organic salt. Always remember this. Alcohol and isocyanate has formed carbamate. These second step structures are not important, but just I have given you some extra knowledge because this time you are going to give board exam. The next one is homologous series. A series of carbon compounds in which same functional group substitutes the hydrogen atom is called a homologous series. These compounds have similar chemical properties due to the addition of same kind of functional group throughout the chain. Please see the second picture. Alkanes, general formula, homologous series alkane. ANE means single bond. Already I have said in my previous video. So general formula CnH2n plus 2. Now you see, if n is equal to 1, so it will be 2 plus 2, 4, and CH4, that is methane. So if n is equal to 2, it will come ethane, C2H6, like this, propane, C3H8, butane, C4H10, like this. Now alkenes, that means double bond present, C double bond C, functional group. So here general formula is CnH2n. So ethene, C2H4, propene, C3H6, butene, C4H8, like this. Alcohols, general formula CnH2n plus 2OH. Functional group bond OH. Example methanol, CH3OH, ethanol, C2H5OH, propanol, C3H7OH, butanol, C4H9OH, like this. Carboxylic acid, Cn, general formula CnH2n plus 1, COOH. Functional group bond COOH. Methanoic acid or formic acid, you can say rather, HCOOH. Ethanoic acid or acetic acid or vinegar, CH3COOH. Propanoic acid, C2H5COOH. Butanoic acid, C3H7COOH, like this.
Good morning class 10 students. Today I am starting with homologous series. Okay. After that I will discuss about functional group. First I am starting with homologous series. So first I am clearing you the definition from your book. A class of compounds with identical functional group. Functional group portion you know. This is OH portion. Suppose this is methyl alcohol. So this OH portion is functional group. This CHO portion is functional group. This COOH portion is functional group. So a class of compounds with identical functional group composed of same elements having similar chemical properties. See this. Same functional group, similar element present, carbon, hydrogen, oxygen, everything present, which can be represented by same general formula. General formula is same of alcohol. For alcohol, this is the general formula. For aldehyde, this is the general formula. For carboxylic acid, this is the general formula. So chemical properties which can be represented by same general formula. Each member of the series differs from the preceding of the or the succeeding member by CH2 group are called homologous series. See this. This is one member of this. This is the series homologous series of alcohol. This is the homologous series of aldehyde. This is carboxylic acid. Homologous series of carboxylic acid. This is the homologous series of alkane. Now see, here CH3, here C2H5OH. What is the difference between this? In this compound, one C is extra and 5 minus 3, that means 2 hydrogen is extra. So ultimately it differs by CH2 group. Again you see from this to this, you see one carbon is extra and 7 minus 5, 2 hydrogen is coming. That means 2 hydrogen is extra. That means it is again differs by CH2 group. You can take this group also same thing. See, one carbon is extra, 2 hydrogen is extra. Here also one carbon is extra, 2 hydrogen is extra. If I write the next compound, that will be also C4H9CHO. That is also CH2 group. You can make the compound then. Here also if I write the next compound, it will come C4H9OH. See, here also same, it will come here also same, it will come obviously next C for compound. And here YNE, triple bond present in an organic compound. So this is the difference between alkane, alkene, alkyne. Already you have studied this type of compound. I am telling you, methane. Methane is a type of alkane because only single bond present over there. Next, you have studied ethylene. Ethylene formula C2H4. Double bond present here. Acetylene, that is type of alkyne because triple bond present over there. Now I am starting homologous series. See the first one, already I had told you. General formula of alkane is CnH2n plus 2. N means any number. Alcohol CnH2n, here plus 2, here plus 1 because 1 is going to here. So OH. Here also same CnH2n plus 1, then CHO because this is aldehyde. Because this is alcohol, organic alcohol, that's why OH group present. Now carboxylic acid means organic acid. COH group present, CnH2n plus 1. Like this it's moving. Now for alkane, CH4, if n is equal to 1, you just put the value of n is equal to 1, it will come CH4. When n is equal to 2, C2H6. When n is equal to 3, C3H8. When n is equal to 4, it is coming C4H10. Hope so you have understood how to make the formula. Now name. You know this name, that is methane. This is ethane. This is propane because 3 carbon atom present. This is butane. B-U-T-A-N-E. Butane. Like this going. For alcohol, this is when n is equal to 1, this will come. When n is equal to 2, this will come. Like this it will go. So name of this alcohol is methyl alcohol. This is ethyl alcohol. This is propyl alcohol. And this is butyl alcohol. Like this it will go. This propyl, butyl, it depends upon the number of carbon atom in an organic compound. Now the next one, aldehyde. Same here, n is equal to 1, n is equal to 2, like this it will move on. N is equal to 3, like this. Now, name of this compound, that is methyl aldehyde or methyl aldehyde. Okay, this is in your book. You will read this, don't worry. You can say this methyl aldehyde or formaldehyde. Now next one, ethyl aldehyde. This is propyl aldehyde. This is butyl aldehyde, like this. Now carboxylic acid, same here. Just change the value of n. So this is acetic acid, it's a very well known acid to you, or vinegar. That is acetic acid. This is ethyl acetic acid, already written in your book. Acetic acid, that is propionic acid, that is butyric acid. Like this it will go. That is pentaric acid, like this. Now you can ask me why I am telling this acid propionic acid. Why? Because I told you it depends upon the number of carbon atom. Here number C2 and 1 carbon is there. So total 3 carbon present. That's why propionic acid. Here 3 plus 1, 4 carbon atom present. That's why butyric acid. So like this it will go on. Hope so. Class 10 students, you have understood homologous series. Yes. Now I am going to. Good morning, class 10. Today I will teach you functional group. It's a portion of organic chemistry. So first, organic compound can be divided into 2 parts. One is hydrocarbon part that includes carbon and hydrogen, and another one is functional group So, functional group is an atom or group of atoms, the presence of which in organic compounds controls its chemical properties, because presence of this group actually it defines what type of compound is it. Is it alcohol? Is it aldehyde? Or is it acid? Or it is amine? Whatever it is. Or it is ether. What type of compound it is. So what type basis on the basis of this, what type of compound it is, the chemical properties of organic compounds will be changed. Okay, so that's why hope so you have understood the definition of functional group. Functional group is an atom or group of atoms, the presence of which in organic compounds controls its chemical properties. Now I am starting this table. First one is hydroxyl group. See, OH. What is this? This is the bond of oxygen. Oxygen valency is 2. So structure is like this. One bond with one bond it is bonding with hydrogen, because hydrogen valency is 1 and another bond is empty. So if presence of this group, so naming like this alcohol, organic alcohol. I am not talking about inorganic alcohol. I am talking about organic alcohol where OH group should be present. CH3 group present, that means methyl alcohol. C2H5 means ethyl alcohol. Like this. Second one is aldehyde. Aldehyde, CHO. Structure, bond, obviously you have to write. This is not dash. This is bond and that is mandatory for writing. So, structure it will draw carbon. Carbon valence is 4, that you know. 1, 2. By these two valencies, it is holding oxygen, whose valency is also 2. Now, by 1 it is holding hydrogen, whose valency is 1. And 1 valency is empty. Now, H, if H will be there, so HCHO. Formaldehyde. This is CH3CHO. Acetaldehyde. It is in your book. CH3CHO. Acetaldehyde. Next one is ketone. Ketone. CO. These are the two empty bonds. So here structure with 2 valency 2. This is holding the oxygen and another 2 are empty. So CH3, CO, CH3. See, 2 portions are empty. If I will write CH3, CH3 like this, that's why I have written CH3, CO, CH3. And CH3, CH2, that means there I will write CH3, CH2 and CH3. So, it is coming, the name of this compound is coming acetone. Acetone. These are ketones compound or ethyl, methyl, ketone. One more thing I am telling you. You can say this is the another name of this compound is there, that is methyl, methyl, ketone. That also you can say. First we will take this side name, then we will take this side name. Afterward, we will mention that ketone. So ethyl, methyl, ketone, and that is acetone. Next one is carboxylic acid. This is the formula. COH, one is empty. Structure is carbon with 2 valencies. One valency with oxygen here, another valency of this oxygen attaches with hydrogen, and another is empty. So HCOOH. HCOOH, that is formic acid, and this is CH3COOH, that is acetic acid. You know the local name present. That's why dimethyl ether or dimethyl ether. Or else you can write this type of compound also, CH3OC2H5. That means methyl ethyl ether. You have to name the compound like ketone compound. First this one, second this one, after that middle one you will mention. Hope so you have understood this function. Okay students, isomerism. The topic is isomerism that I am going to discuss now. So isomerism. What is isomerism? The phenomenon of existence of different compounds with different properties having the same molecular formula is called isomerism. That means molecular formula is same, but structure is different. That is called isomerism or structural isomerism. Existence of different compounds having the same molecular formula but different structural formula is called structural isomerism. Structure is different but molecular formula is same. So one thing I want to tell you, in your book there are two definitions. One is isomerism, another one is structural isomerism. If question will come, what is isomerism? So please give the definition of isomerism. If question will come, what is structural isomerism? Please give the proper definition of structural isomerism. Read the question properly and then give the answer along with one example. Example now I am giving. Now see, first one. See this chart. It is from your book only. This is ethyl alcohol. This is ethyl alcohol. And this is dimethyl ether. Okay? See here. How many carbon? C2. How many hydrogen? 5 plus 1, 6. Molecular formula means at a time I am writing. I am not arranging this. I am just writing. Okay? This is general normal formula that we are using. That is molecular formula. That is structural formula. You have to know what is the difference between molecular formula, structural formula, because here we are showing the exact structure and here we are showing the molecule. Means within our molecule, how many carbon atoms in total are there? How many hydrogen atoms in total are there and how many oxygen atom is there? That only we are telling. And here we are giving the general formula. Now, this is molecular formula and dimethyl ether molecular formula also 2 carbon C2, 3 plus 3, H6 and 1 oxygen present. So both of them molecular formula is same. Now isomerism, structural isomerism. See the structure. Structure differs. Carbon OH group present like this and here this structure is present, ether. Here this ether structure is present like this. Just they have arranged themselves in a different way like this in a classroom. One day you are sitting like this. Maybe you have remembered the rolling system and the next day you are sitting in another bench. That means you are sitting in class 10 room only. Like this molecular formula. All of you. Same number of students. But you have arranged yourselves in a different way. So like this structural formula. Okay. This is here the alcohol group present. Now structural isomerism. Structural isomerism are divided into two parts. One is functional group isomerism and another one is positional isomerism. Functional group isomerism. CH3. Just count this with this carbon. How many hydrogen are there? CH3. CH3, CH2OH. And here CH3O, CH3. So this is functional. See, functional group differs. Functional group differs. Try to understand that. Ether and this is alcohol. Functional group is different, but CH3, CH2 means total number of carbon, total number of hydrogen same. They are just arranging themselves in a different way. So where functional group is different, that is called functional isomerism. And where positional isomerism means, positional isomerism, you see the structure CH3, CH2, CH2, OH. Here OH is here and here OH is here. That means the first compound name in your book also you can see, don't worry, I have given from your book only. That is propan 1-ol. Why propan? Because 3 carbon is there, that's why propan 1. If you will number it 1, 2, 3, like this you can number the carbon atom. So with the first carbon atom, all group is present. OL, that means OL group means OH group present. Later on I will teach you IUPAC name. Then I explain you this. So propan 1-ol or N-propyl alcohol. N means N is unknown number. N-propyl alcohol. That means here functional group attaches with the carbon at the either this side or that side, not in the middle. In a simple word I will tell you. And this one is isopropyl alcohol. Why? Or else in your book written propan 2-ol. You see 1, 2, 3. Here with number 2 carbon, this OH group attaches. So either propan 2-ol or isopropyl. Iso means branch here. Okay. That means in the middle one. With the middle one, an OH group attaches. That's all. This is the isomerism. So class 10, this is your homework. First one, define structural isomerism. Give one example of functional isomerism. Okay? Example, give one example of functional isomerism means you have to write down 2 formula with structure. Next, what is homologous series? Define. What is the next formula of formic acid? Just write down the formula and name both. If you add CH2 group to formaldehyde, what will be the formula? Here also name and formula both. Next, number 4, write the formulae. Ethyl, methyl, ether. Okay? And propyl alcohol. For any queries or doubts, please email me at sudeshna1.sma@outlook.com. Send your homework at sudeshna1.sma@outlook.com. Thank you.
For any doubts or queries, please email me at sudeshna1.sma@outlook.com, or you can share your each and every doubts in my Zoom class. We also welcome your responses by way of your views and feedback on PPTs or videos at feedback.stmichaelsacademy@gmail.com. Thank you, students, and have a nice day.